Alright, so here we are with Unit 12, Lesson number 4, and we're going to look at the remaining types of natural decay. We're going to look at positron decay, and as I had said to you before, it's not asked about a lot on the Regents exam, but I'm going to go over it anyway. And if you take a look at, here's the example at the bottom here, so let's quickly run through that. Notice what happens is similar to what happens in a beta decay. I'm just going to go right to the examples since they don't really ask you a lot about it. So here's a couple. I'm only going to do the first two. So again, potassium, this particular isotope of potassium is unstable. It's going to give off a positron, but notice now this charge is a +1, so I have to be very careful. The mass is still going to be the same. It's still going to be 37 for the new element. But now I see this is a +1, so my new element has to have an atomic number of 1 less than the original, which is 18. So now I go to the periodic table, and number 18 would be argon. Again, 37 and 0 is 37. 18 plus 1 is 19. Let's go through this. I'm going to do it this way, and this, so you don't get into the bad habit of thinking it's always in that order. That's a positron. I know it's going to be 81, the new mass, and I know that the new atomic number has to be 1 less than the original, is going to be 36. I go to the periodic table, and number 36 is again another noble gas, is krypton. You should do the last one on your own. It is going to be graded, so you need to make sure that's done. Let's look at the last one. Now, one of the interesting things about gamma rays is that when they are given off by a nucleus, since gamma rays have no mass or charge, it doesn't really affect, it doesn't really give off a particle. It's just giving off energy, and it's in essence X-rays. So there is no gamma equation like you had for alpha, beta, and positron. So when gamma rays are given off, again, that's pretty much similar to X-rays, high energy X-rays. So no new element is formed as a result of gamma rays being given off. But remember, gamma rays are extremely dangerous. And they have no mass, they have no charge. And that's it for